certain question is always in mind before embarking upon the main topics of the paper, that is Metamorphic Petrology and Thermodynamics, which is a branch of geology or applied geology. Why to read Metamorphic Petrology, history of Metamorphic Petrology, significance of Metamorphic Petrology and Thermodynamics. Dear student, I am Dr. Harold Thomas, Professor in Applied Geology, Department of Applied Geology, Dr. Hari Singh Gaur Vishwavidyalaya, Sagar. Today, in this course, I will deliver my lecture on an overview of Metamorphic Petrology. In this lecture, I will proceed under the following heads: Introduction, late 17th century, beginning of 20th century, late 20th century and 21st century. I will cover this topic in two parts so that it will be good for the student to understand the whole topic properly. I believe it will be useful for you before embarking upon the main topic of the paper, that is Metamorphic Petrology and Thermodynamics. Since 20th century, Metamorphic Petrology advances very rapidly. Still, very less compilation work is done. I am trying to attempt the advancement of the subject in terms of field theory, experimental works and application of new technology for proper understanding of the subjects for the younger generation. The historical development observed by the different milestones, it is first concept based and convey to the student how an idea evolved with time to be a landmark of metamorphic petrology. We know how the metamorphic starts, what are factors responsible for this, how it proceeds and why it stops. The answer we can find out through the relation of metamorphism and igneous activities, documented in terms of texture, mineralogy, chemical changes and calculated pressure temperature condition, and through all these one can draw the PT path and predict how the metamorphic rocks is evolved. Metamorphic petrology is started in the late 17th century when James Hutton of the Edinburgh observed that some deeper rocks show a gradual transition from sedimentary rocks to those whose mineralogical composition and structures have been caused by other than sedimentary. Charles, 1833, recognized the role of heat and fluids in the transformation process, which he called metamorphism. In his book Principle of Geology, in the year 1893, when George Barrow mapped south of Aberdeen in Scotland, observed the zones or series of the progressive metamorphism in the peltic sediments of the Durlandian series and observed the 6 different zones on the basis of index minerals. These are chlorite, biotite, garnet, stolite, kyanite and sillimanite. With increase of temperature, the boundaries between two minerals is called isogard. The isogard is a line of equal isothermal surface. This type of metamorphism is referred to as Barrovian type metamorphism or progressive metamorphism. or regional metamorphism, or even we can say kyanite sillimanite type metamorphism, which was subsequently recognized in several metamorphic terrain of worlds including India. Austrian geologist Friedrich Becke in 1903 treated metamorphic assemblages due to pressure and temperature. Both increase with depth. He recognized two depth zones of regional metamorphism. Grobenman and Nigli 1924 established three zones: epizone, mesozone and catazone, which are equivalent to low, medium and high grade of Winkler 1979. Goldsmith introduced the phase rule to geology in 1911, known as mineralogical phase rule. He stated that in equilibrium state, the number of minerals or phases in a metamorphic rocks equals the number of components, because natural rocks are normally subjected to divariant condition, that is F equal to 2, that is F equal to C plus 2 minus P, or P equal to C at divariant condition. Ascola applied the phase rule for developing the graphical diagrams of mineral equilibria in ACF and AKF phase diagram. The ACF diagram provide useful to show major phases change, to deduce mineral reaction and to relate mineral assemblages to the bulk composition. Thomson developed the AFM projection in year 1957 for peltic assemblages in the Al2O3, K2O, FeO, MgO projected from Muscovite points. Application of phase rules and the graphical distribution of univariant assemblages in PT space were formulated by Sinemakers in his series of research paper and today known as Sinemaker rules, and very much useful for phase diagram for multi-component system and to understand the metamorphic reaction and stability. Metastability of assemblages in specific rock system, PT and given proportion of components, thermodynamics, base projection, T-X or P-X proposed by the Greenwood 1967 methods. Comparing the mineral assemblages of different bulk composition studied by Goldsmith and Ascola, the differences in mineralogy was conceived by Ascola to represent two different phases, establish a new concept of metamorphic phases. Turner and his co-authors enlarged the number of phases and gave approximate range of pressure temperature for each metamorphic phases on the basis of known thermal stability of minerals. Mayasiro in 1961 realized that regional metamorphism varies from place to place in a plate tectonic setting. Mayasiro originally recognized three different metamorphic phases series. These are phases series were produced by metamorphism under different pressure condition. For example, high pressure, intermediate pressure and low pressure. First, a geolite, prehenite, pumpelite, blue schist, eclogite phases. Second, a typical Barrovian type characterized by kyanite to sillimanite type. And third, an Abukama type of green schist, amphibolite, gaulite characterized by the paragenesis of Andalusite and Sillimanite type. The Abukama type is named after the Abukama region in Japan and is similar to the Buchan type of the Dalendian. Each facies series therefore characterize a baric type of metamorphism and on the basis of pressure named as low pressure, medium pressure and high pressure, and also designated by the geographical names, for example, Abukama, Barrovian, Franciscan facies series, characterized respectively by Andalusite Sillimanite type, Kyanite Sillimanite type and Jadeite Glaucophaene type. In this lecture, I will proceed under the following heads: late 20th century and 21st century. In my previous lecture, I have covered introduction, late 17th century and beginning of 20th century. I believe it will be useful for you before embarking upon the main topic of the paper, that is metamorphic petrology and thermodynamics. Zonal or facies concept still have application in low or very low grade of metamorphism. The facies concept somewhat difficult to apply in high grade rocks because still no realistic quantitative model to explain how the regional metamorphic area is heat up, and second, development of technique for calculating metamorphic pressure and temperature. England and Thomson 1984 given the new concept of heating of metamorphic belt. According to this model, tectonic processes operating at plate tectonic velocities perturb the thermal structure and thus in turn result a characteristic PTT path of the rock evolved. The PTT path followed by rocks depend on many factors such as the style of deformation, thrust, folding and magma intruded, erosion rates and duration of orogenic events. On each path, there is obviously only one point that reflect the maximum temperature T max, where peak metamorphic mineral assemblages will show the load pressure at temperature maximum. The pressure at temperature maximum is less than the maximum pressure P max experienced by the rock. Modern metamorphic petrology reached maturity in the 20th century, especially in last few decades after the use of EPMA in France by Raymond, who built the new instruments in 1951. The mineral analysis done by the EPMA are being reliable used for determination of pressure temperature condition. The application of thermodynamics to the petrology, the basic equation relating to solid phases delta G0 equal to 0 equal to delta H0 T delta S0 plus P minus 1 delta V0 plus RT ln K, and used to calculate the temperature and pressure using thermodynamic equation given by different workers. Several garnet biotite exchange thermometers were derived based on experimental and empirical. Dasgupta et al. 1991 and Bhattacharya et al. 1992 have given garnet biotite exchange thermometers. Bhattacharya et al. 1988 have also formulated corderite garnet thermometers and garnet corderite sillimanite quartz barometer. Bhattacharya et al. 1991 Garnet OPX plesioclase quartz barometer and Garnet OPX geothermometers. Lal 1993, Bhattacharya et al. 1991. MPET software to calculate the pressure, temperature and activities of common metamorphic minerals developed by Thomas 1994 based on formulation given by different workers. Thermobarometry for common rocks have been in use directly or indirectly from empirical observation of LNKD variation. For example, Thomson 1976 to calculate the pressure, temperature or fluid composition computer programs are available, namely Thermocols, Powell and Holland 1988, Holland and Powell 1990, GeoCalc, Berman et al. 1987 and Twick, Berman 1991-1992. For routine thermometry and barometry, exchange and net transfer reaction were formulated from time by petrologists, and based on these formulation, MPET softwares developed by the Harold Thomas 1995, 1998, 2006, 2008, Thomas and Lalu Podial 2016 based on formulation given by different workers. Metamorphism is a dynamic process and freezing of minerals composition is a remote possibility, and considering the possibility of having minerals of more than one metamorphic events. Metamorphic petrology use compositional zoning in minerals, for example, garnet, since garnet grow early in metamorphic process and responds to change in the physical condition of metamorphism. This mineral has been used to a portrait pressure temperature evolution of the garnet bearing assemblages. The beginning of 20th century witnessed a long drawn controversy on the origin of ganulites and migmatites. Slater Holmes in 1907 postulated that crustal rocks underwent partial melting at greater depth where temperature exceed 650 degrees centigrade. This melting at depth result into the outcrop scale mixture of light and dark colored rocks were called migmatites. Hydrothermal experiments by Tuttle and Bowen 1958 revealed a correspondence of ternary eutectic in quartz albite orthoclase system with the normative proportion of felsic components from different granitic rocks and from rhyolites, whereby hypothesis of metasomatism was rejected for origin of granites and migmatites. The actual laboratory techniques for determining the so-called isotopic or radiometric ages are extremely complex. There are several methods like uranium lead, rubidium strontium, samarium neodymium, potassium argon, lead lead, argon argon, which are used in selected minerals and rocks. Recently, even zoning in minerals like zircon are dated by ion probe SRIM and other methods. Besides geochronology, geochemistry of the metamorphic rocks has advanced the history of the rock of the Earth's crust. Geochemistry deals with description and distribution of elements and their isotopes in various parts of the Earth, atmosphere and hydrosphere. In metamorphic petrology, it has been noticed that geochemical scale imposes constraint on what can happen when new materials are brought to the surface from interior of the earth. Now the stable isotopes have become an integral part of the research in metamorphic petrology. The earth crust and lithosphere are the repository of the geological records and have been responded to changing geothermal regime. The Precambrian records is characterized by distinctive crustal association and internal processes. Metamorphism, deformation and magmatism. Metamorphic petrologists need to be reorient themselves from traditional research which deals with fresh rock sample petrological and mineralogical studies in the alteration process, including retrogression by shearing. Very complex chemical processes take place which needs to be studied by analytical techniques, including the study of fluid inclusion, stable isotopes, etc. The fluid rock interaction needs serious attention of petrologists. The metamorphic petrologists need education in geochemistry, hydrology and mineralogy, because petrology is advancing on all fronts with a powerful combination of observation, experiments and theory. Metamorphic petrologists can successfully study fluid flow in veins and whole rock outcrops in collaboration with engineers and physicists. It provides new methods for studying structure of minerals as well as melts and solutions. Nanosciences has now taken its roots in geological sciences, so has the geobiology, geomicrobiology. Collaboration with biologists and chemists should help in understanding roles of organic matter in the formation of low temperature ore deposit. It is really unfortunate that our university and college training in earth science do not provide the environments and infrastructures for advanced research. Funding agency should care for good research in the geological sciences, especially in the field of natural hazards and hydrogeological and soil and environmental studies. Dear student, today we have discussed in this lecture about the late 20th century and beginning of 21st century. Hope it will be useful for all of you before embarking upon the main topic of the paper, that is metamorphic petrology and thermodynamics. For further studies, please read the books and references given in the text. Thank you very much.